Hey guys, welcome back to another video. So today what we're going to be focused on is learning how to use the addition operator, subtraction operator, multiplication, division, and modulus. The modulus is probably newer to you guys. You probably don't know what I mean by the modulus operator, but we'll figure it out. So let's just start by creating a simple program. So what we're going to do is we're going to include our iOS stream, are using namespace std and our main function. So how do we use these operators up here? So let's say we have an integer x that equals, let's say, 2, and we have an integer y that equals 3, and we want to store that in z. Z has no value yet. I haven't declared it a value. So z equals 2 plus 3. So the value of z, we can actually print that out. The value of z is space, and it's going to be z. Okay, guys, so what I'm doing here is I'm declaring 3 variables right here. I'm saying that x equals 2, y equals 3, and I'm just declaring space. I'm just allocating space for z, but I'm not doing no value. And if you guys aren't used to seeing it like this, it's the same as doing this. So what I'm doing right here, int x equals 2, comma, y equals 3, comma, z is the same thing as these 3 right here. As you can see, you have to put more work into. You have to put a couple more ints into there. You got to separate them. So usually it's much easier doing it like this. So when I wanted to declare the value, when I want to change the value of z, I don't have to declare int again because I'm not allocating space for it. There's already space in memory for z. So I can just refer to it as z. And what I can do is I can add, not 2 plus 3, I'm sorry. I can do 2 plus 3 if I want, but I can add these 2 variables, x plus y. Let's keep a space in here. I can add these 2 variables, x plus y, and it would be 5 because x here equals 2 and y equals 3. So let's do this program real quick. Let's see how it looks. So it's just a simple arithmetic. It's going to be the same things for subtraction. As you can see, the value of z equals 5. And we'll have a new line here. It's going to be the same thing for subtraction. Z equals, let's say, x minus y. Alright, so see out. The value of z is alright, and let's see the second one. So the first one should be 5, and the second one should be negative 1. So the value of z is 5, and the value of z is negative 1. So same thing with multiplication. Z equals x times y. X times y. See out. The value of z is, and line. So what this is going to be is 2 times 3. That's going to be 6. So 5, negative 1, and 6. Oops, pressed the wrong one, I believe. Yes, the value of z is 6. The value of z is negative 1. And the value of z is 5. Same thing for multiplication. But the thing is, it'd be much better for me to declare them as doubles for multiplication. Because here, you'll see what happened. Divide 3. See out. So this value is not going to be what you think. And the line. So I changed the value of z to x divide y instead of 2 divide 3. I keep doing that for some reason. But I want you guys to see what the value of z is. What do you think? What do you think it's going to be? So we debug it. And the value of z is 0. Why is it 0? Because this is an integer. These are all three of them are integer variables. If you think about it, z is an integer variable, so it can only store integer variables. X divide y is 2 divide 3. So the value should be 0.6666, right? But it can only store the integer variables. It can't store the decimal value. So what it does, it rounds down to the nearest integer. So that means it's going to round down to 0, right? And if we change this to 4 divide 3, what do you think the value is going to be? So that value is going to be somewhere around like 1.3, right? But since this is an integer variable, it's going to round down to the nearest integer, and that's why the value of z is 1. You can keep doing this for as long as you want. Let's say we have it at 7. So that means the value stored in z is going to be 2. And of course, all these other values change because the values of x and y change. So we can put that back. And last but not least is the modulus operator. So the modulus operator is different, guys. So here's an example. 7 modulus 3. It's used the same way as like a division operator, but what it does, it finds the remaining value. So look at it. How many times does 3 go into 7? It goes into 7 3 times. 6, right? But it has the remaining value of 1. So the modulus operator is going to store this value right here. So what if it was 7 modulus 2? How many times does 2 go into 7? It goes into 7 3 times, right? But there's, I'm sorry, it goes into, the highest value goes into 6. But the remaining value is 1. What about modulus 7 with 5? So 5 goes into 7 one time, right? So that value is 5. But it has a remaining value of 2, because 5 plus 2 is 7. 6 plus 1 is 7. 6 plus 1 is 7. So it's the remaining value that's left over. And 7 modulus 4. Right? 4 only goes into it once. So the remaining value that's left over is 3. But what if the value is smaller than what it's being divided by the modulus, right? So 2 modulus 3. So it goes into 3. 3 goes into 2 0 times. And there's a remaining balance of the top. Should be 2. And let's say 2 modulus 16. 16 goes into 2 0 times. Right? 0 times. And there's a remaining value of 2. So we'll just show an example with it being actually there. So z equals x modulus y. See out. The value of z is z, an n line. So what are we looking at? X is 2, right? X is 2, y is 3. So we're doing 2 modulus 3. 3 goes into 2 0 times right here. 3 does I'm sorry. 3 does not go into 2 at all. So there's a remaining value of 2. So the value that z stores is 2. We can see here. And there you go. What I like to use the modulus, or what's very common to use the modulus operator for, is if you're checking to see if a value is prime or even, if it's odd or even. Because if the modulus, let's say we have a value z, let's put this down. Let's say we have an integer z, let's say equals 17, right? And we want to find to see if it's a even number, right? So z divide 2, z modulus 2, and we'll learn about this later in if statements, checking to see if it's correct and to print out that statement. But we're going to see if it equals to 0. Because if it's even, right, modulus 2, that means 2 goes into it perfectly. So that means there's no remaining value. But if c is a odd number, for example here, it'll go into 16, right? And there'll be one remaining value. So that's how you can check. Here we'll put 18 and not a remaining value. So 18 modulus 2, this is an even number. This will happen with all even numbers. It goes into 18 9 times perfectly. There's no remaining value left, so the remainder will be 0. But if it's an odd number and you do a modulus of it, it would be, for example, for 17, it would go into 16. It would go in there 8 times. 8 times 2 is 16, but there's one remaining value. So that's a way you can check to see if a number that's inputted is even or odd. Well, guys, I know this was just an introduction into these operators. I know the modulus one can be a little confusing at first. Most of you, if you guys never coded, then it's probably a new concept for you guys. But it's simple once you learn how to work with it. Well, if you guys liked the video, please leave a like, comment, and subscribe to my channel. Thank you, everybody.